In this study, we investigated which brain regions are involved in encoding the identity and orientation of faces and bodies. Previous studies have shown that regions in occipital-temporal cortex show particularly strong responses to particular categories. For example, stronger responses to faces compared to objects or to bodies compared to objects. We were interested in how these regions might be encoding face and body information. Previous studies have shown that there are differences in face-responsive regions, with some regions encoding face identity in an orientation-invariant manner, and some regions encoding face orientation. So we were interested if there might be similar differences between the body-responsive regions. We were also interested if there might be regions that encode orientation or identity in an abstract manner that could generalize across images of the face and body. To investigate these questions, we created a stimulus set of free identities where we created images of the face and the body from 3 different orientations. We trained participants to recognize these free identities prior to the fMRI experiment, and after this training, participants could easily recognize all identities from both the face and the body. We then showed participants these images while recording their brain activity using fMRI. Participants had 2 tasks. One was an attention task where they responded whenever they saw a small image size, and the second was either to respond to which identity or orientation was shown in the block, and half of the experiment they performed each of those tasks. We then performed decoding analyses to investigate how orientation and identity are encoded in the brain. For decoding body orientation, we extracted patterns of activity evoked by each of our conditions in the body-responsive regions, and we trained a classifier to distinguish between patterns of activity evoked by the 3 body orientations from 2 of the 3 identities. We then tested the trained classifier on its ability to distinguish between the 3 orientations from a separate dataset when people were looking at the 3rd identity. We performed these analyses separately for activity when people were performing the identity and orientation detection tasks to see if responses to orientation might be enhanced by participants' attention to this feature. What we found was that we could decode orientation from the extrastriate body area but not the fusiform body area, and attention to orientation didn't seem to affect the neural responses. We then did the same thing but to see whether we could decode body identity. Here we trained the classifier to distinguish between patterns of activity evoked by the 3 different body identities from 2 of the 3 orientations. And then we tested the trained classifier on its ability to distinguish between the 3 identities, again from a separate test dataset and from the 3rd orientation. So there had to be some sort of generalization across orientation for successful decoding. What we found was that we could decode body identity across orientation from the fusiform body area, but not the extrastriate body area. And this was only possible when participants were attending to identity, not when they attended to orientation. So what these 2 findings show that there's a distinction between the brain regions encoding body identity and body orientation. And interestingly, body identity responses seem to be enhanced by intention, but body orientation responses seem to be not affected by the behavioral task. We then investigated whether there were brain regions that encoded orientation or identity in an abstract manner. For orientation, we trained the classifier to distinguish between patterns of activity evoked by the 3 body orientations. And then we tested that trained classifier on its ability to distinguish between patterns of activity evoked by the 3 face orientations. And we also did this vice versa for training on faces and testing on bodies. We found that we could decode orientation in a stimulus-independent manner in an area bilaterally in the posterior occipital-temporal cortex. We then did the same thing, but for decoding identity. And here we found that only during the identity detection task, we could decode identity across face and body from a network of brain regions. What these findings show is that posterior occipital-temporal cortex seems to encode orientation in a stimulus-independent manner, and a network of brain regions seems to encode identity in a stimulus-independent manner. Finally, I'd like to thank all the people involved in this work, and please get in touch if you would like any more information.